All right, thank you all for attending. I'm excited to share with you some info on air source heat pumps and cover the details of Hmlp's air source heat pump program. So with that said, please let me introduce Tom Moran, General Manager for Hingham Municipal Lighting Plant.
Good evening, everyone, and thanks for coming out again tonight. I know some of you may have been on our webinar last night on our transmission line. So again, thank you for coming out again. Hmlp partnered with Abode to create a resource for our customers, for any customer that might be exploring a conversion to heat pumps from fossil fuels. Abode is well versed in the use of heat pumps. So this is an opportunity for Hmlp to help educate our customers on how heat pumps function and their capabilities, to provide heat as a source, a clean electric source rather than a fossil fuel source. So again, I think you'll enjoy Chris's presentation, and at the end, we're more than happy to try to answer everyone's questions.
All right, thanks, Tom. So yeah, my name's Christopher Herringa. I'm the program manager at Abode for our air source heat pump rebate programs, and we'll be holding questions at the end, like Tom said. So feel free to put those in the chat boxes, the Q&A, whatever, and we'll get towards the end there. So just to start off, I'd like to give you some more information about Abode. All right, so we are a local small business based out of Concord, Mass. We run 11 decarbonization-related programs to increase heat pump adoption. Since launching this program last year, we've connected with well over 1,100 households to help them learn more about heat pumps, and we've conducted technical reviews on nearly $7 million in projects. So we don't sell heat pumps, although we used to be contractors ourselves. We are a third-party objective team that provides advice to customers, contractors, and utilities around clean heating and cooling solutions. We also oversee a large portion of the Mass Save program on behalf of National Grid, specifically the residential customers that use home performance contractors to access the no-cost Mass Save energy assessments and the incentivized weatherization benefits. And in Connecticut and New Jersey, we support contractors offering virtual assessments as a way to help residents access the benefits of energy efficiency programs in a safe way. Here are many of our clients. As you can see, we're working with many municipal light plants to support the adoption of clean heating and cooling technologies. So our background as contractors, program administrators, utility consultants, and lead vendors gives us a unique perspective on the goals of each of these different stakeholder groups. And so many of us are also customers in these different programs. So being able to evaluate every situation with each of these lenses enables us to support folks throughout their projects. This photo here on the right is of our VP of Operations doing a deep energy retrofit on his own home a few years back. So one of the biggest ways that residents can get help is through the no-cost conversations provided by Hmlp through Abode. So during these consultations, we work to understand your goals, motivations, and your home's needs, so we can help you make an informed decision with confidence. Heat pumps can work in all kinds of homes, from single family to multifamily. So with heat pumps providing a huge variety of solutions for all kinds of spaces, we can help homeowners meet their heating and cooling goals, whatever those might be. So through these consultations, we're happy to cover whatever your needs are, whether that's a general conversation about heat pumps, what they are, how they work, or if you need some support evaluating multiple bids you're looking at, we're here to help. At the end of the day, we want you to be prepared to move forward with heat pumps with a contractor of your choosing, if it makes sense. The upfront advice we provide is intended to be a starting point for most folks, and your contractor who is in your home taking real measurements, doing load calculations, and assessing the site conditions should be best situated to properly size and design a system that meets your needs. But when you have questions though, we're always here to help. So now let's take a look at heat pumps in a bit of detail, starting with how do these things work? So a heat pump is a versatile, efficient cooling and heating system that operates using electricity. Heat pumps do not burn any fuel. They move heat from one place to another. So to provide heat, a heat pump works by extracting heat from the air outside of your home and transferring it to refrigerant. And it can do that even when it's extremely cold outside. The refrigerant is then compressed, which increases the temperature significantly. That hot refrigerant is then moved to the indoor unit of the heat pump, which then passes air over the hot refrigerant and transfers it to the indoor air. When in cooling mode, a heat pump and an air conditioner are functionally identical, absorbing heat from the indoor air and releasing it through the outdoor unit. So when in cooling mode, the refrigerant that is moving to the indoor unit of the heat pump is very cold, allowing it to transfer cool air to the space. This chart shows the breakdown of the year built of homes who have adopted heat pumps in our programs. So for example, of the homes that have installed heat pumps, 25% were built between 41 and 60, and about the same percentage of heat pump adopters had homes built between 61 and 80. So homes of all ages and sizes are installing air source heat pumps, and about 71% of homeowners purchase heat pumps to reduce or stop using their fossil fuel system. Here we can see how much of the home heat pump adopters are typically conditioning with heat pumps. So this doesn't mean they have removed their old heating systems, but that the heat pumps they installed service or condition that percentage of their home's square footage. So for example, 27% of homeowners are choosing to condition 100% of their homes with heat pumps. And 58% of homeowners keep their existing system only as a backup to the heat pumps if needed. Let's take a look at operating cost of heat pumps in Hmlp's service area. So this chart uses Hmlp's residential cost of electricity per kilowatt hour to represent the operating cost of air source heat pumps during the heating season. It uses 16 cents per kilowatt hour as the all-in rate for residential customers. So heat pumps are 2 to 4 times as efficient as a gas furnace, even in the coldest climates. This technology has come a long way from traditional electric heating and offers efficiency that fossil fuels can't match. So air source heat pumps, they deliver heat at progressively lower costs, the warmer the outdoor temperature. So as you can see in the chart, we spend about 80% of our heating season between 32 degrees and above, and only about 20% below freezing. The overall average of the season is represented by the green bar with the arrow, and the bars following it to the right show the cost depending on the outdoor temperature. As you can see, it's highly cost competitive against all other fuel types. While some customers opt to keep their existing system for days when it's extremely cold, many households will use heat pumps year-round and are still totally comfortable. And noting the value of cooling as well, air source heat pumps are extremely efficient at providing cooling in the summertime. So heat pumps can be twice as efficient as window ACs, and many models offer improved efficiency over central air as well. So upgrading from an old window AC or an old central AC could result in a 50 to 100% increase in efficiency. So a few key points to remember. First is that air source heat pumps operating cost is cheaper than oil, propane, wood pellets, and electric resistance. And depending on how efficient your natural gas system is, seasonal operating costs can be similar. So for example, if you have an old natural gas steam boiler with radiators, it may be more costly than heat pumps to run even when very cold out. And if you have a new gas condensing boiler with forced hot water, it may be more representative of the chart above. And second, the cost of electricity is steadier and more predictable compared to fossil fuels over time. And this chart examines how many tons of CO2 emissions heat pumps versus traditional heating systems create over the course of 20 years. So including emissions from the fuel, heat pumps have the lowest emissions. However, heat pump operating emissions are indirect, you could say. So air source heat pumps have no direct emissions from the operation of the unit itself, whereas fossil fuel systems burn fuel at the unit and have direct emissions from operation. This chart uses New England's electricity generation mix to calculate emissions for heat pumps. The cleaner the electricity is produced, the cleaner air source heat pumps will become. And if you're purchasing solely renewable energy, or if you have enough solar at your house, your operating emissions could be zero. Hmlp's electricity generation mix is even cleaner than the representation above, so operating a heat pump in Hmlp's service area will have even lower emissions. Plus, another nice thing about being a customer of a muni light plant like Hmlp is they have the opportunity to be more progressive and expedite the adoption of cleaner energy versus larger entities. So some key points here: energy production is getting cleaner every year, which means heat pumps' carbon emissions are reduced year after year as well. And heat pumps over the lifetime of operation have the lowest emissions. We're seeing a real diversification in the kinds of configurations of air source heat pumps. So let's go through a little bit of that. Air-to-air heat pumps, or heat pumps that use the air outside to heat or cool the air inside, are the biggest share of the market today. This has been driven by the growth of ductless air source heat pumps, or ductless mini splits. And that's probably what most of us are familiar with and have seen in homes, shops, restaurants in the area. That's just one of the configurations that you can use in the air-to-air category. You can use more traditional centrally ducted systems. You can use one-to-one systems that are just one outdoor unit with one indoor unit, like a ductless mini split. There are even multi-zone systems now that you can match one outdoor unit with multiple indoor systems. And there's everything in between in terms of combining the different indoor units. And we'll talk some more about that in a moment. So a few reasons why air-to-air is the leader. The install for ductless units is quick and relatively straightforward. They are versatile and compatible enough to work in most homes to offset or provide all of your heating and cooling needs. And they're the lowest cost to install compared to other types of heat pumps. Another opportunity is air to water. So using the same technology, but transferring that heat throughout the home with water, with hydronic systems that use baseboards, radiators, or radiant floor heating. There's a lot of really cool opportunities out there with new construction, but some challenges on the retrofit side with retrofitting existing hydronic systems. The hot water generated by air to water heat pumps is not as hot as the water generated by traditional boiler systems. And that lower temperature water from air to water heat pumps requires a different type of hot water baseboard or radiator to keep the house warm enough when it is cold outside. So it's not always a good fit when trying to replace your existing boiler, and you can still consider air-to-air heat pumps as an alternative. As this technology develops in the years ahead, we'll likely see some more of this stuff becoming a possibility. And there are other types of heat pumps more on the water side, such as geothermal or ground source heat pumps. And so similarly, you're harvesting that energy from the ground or from water, and you can distribute that into your home in multiple ways, whether you're doing it through air handlers or through hydronic systems. So there are a lot of ways to mix and match this technology, depending on your needs or preferences. Today, we are focused on air-to-air systems. So let's focus some more on the types of indoor units that you can use with air source heat pumps. Ductless units are versatile enough that you can size them to heat and cool larger open areas or even small bedrooms or offices. There's a lot of form factors when it comes to the ductless systems. So starting with the wall hung unit on the left that most of us are familiar with, this can easily be hung on exterior walls and sometimes interior walls, depending on the situation. And you can get a floor mount unit that looks a little bit more like a floor radiator, at least in where it would sit. These are becoming increasingly popular and are a great alternative to the wall hung units. And then there are ceiling cassettes. So these can be mounted into your ceiling. The bottom picture in the ceiling cassettes category is a bit of a newer product that does a better job of fitting between the joists in the ceiling, which was previously an issue in terms of fitting some of the ceiling cassettes. So again, there are some new technologies coming out all the time to make installing this stuff very practical. So we're also seeing more and more ducted systems, mini ducts and compact ducts. We have a lot of different names, but essentially the mini and compact ducted units can be set up with some amount of short run, slim ductwork that allows you to use one unit and impact a few different smaller rooms. These can be really handy to use in parts of the home where the bedrooms and bath are located so that each room doesn't require a ductless unit. And these units are growing in popularity. The industry might be a little more comfortable with centrally ducted units. And if you're interested in some of that technology, we're here to help you find the right contractor if that makes sense for you. So these units from the low static product on the left that could probably only serve 1 or 2 rooms to a medium static product that can serve a whole floor, maybe 3 to 4 rooms. And then finally on the right, the more traditional high static centrally ducted product that could serve a whole house. So you can see here, there's a lot of variety on the design side that you can leverage to find a solution that makes sense for your home, both functionally and aesthetically. And you can mix and match what you have in your house, and design that's growing in popularity is to utilize a compact ducted unit for the bedrooms, bath, and hallway part of the house, and the ductless units to serve the more open living area of a home. So it's important to articulate your goals and motivations well to a contractor so that in turn you can get a quote for a system that is designed to meet your needs. So is your goal to save money, increase comfort, reduce your carbon footprint by reducing fossil fuel usage? How much of the home are you trying to heat? Do you plan to keep your existing system? And if so, how often do you plan to or want to still use it? So if you plan to heat and cool a substantial portion of your home with air source heat pumps, it's important to ask your contractor if they will run heat load calculations rather than use rule of thumb. Sizing heat pumps correctly from heat load calculations reduces the risk of performance, efficiency, or comfort issues. And if you will keep your existing heating system running in tandem with an air source heat pump, it's important to consider how the existing heating zone or zones will interact with the area the heat pump will be servicing. So there are a number of good strategies to address this, including integrated controls. Integrated controls are thermostat systems that can talk to your heat pump and your existing system. And if controls won't work for your specific scenario, then there are a couple ways to stage the existing system and the heat pumps so they work together instead of compete. As we've learned a little so far, there are many ways to design these systems to meet your needs. You can leverage the different types of indoor units to match the needs of your space that you want to condition. So open floor plans work great with ductless units, and 1 or 2 ductless heads can condition a large area. And compact ducted units can service areas with isolated rooms. Small single zone units are great supplemental heating and cooling additions to cold or hot areas of a house, or they could be used to provide all the heating and air conditioning to a room or a new addition. You can connect multiple indoor units to one large outdoor condenser, or you could break it up to multiple smaller outdoor condensers to improve control and efficiency. So as I just hinted there are some pros and cons of single zone versus multi-zone units. So single zone or one-to-one units are incredibly efficient at both heating and cooling. The outdoor condenser can connect to a ductless unit as shown, or a ducted unit. And depending on the size of the outdoor condenser and the type of indoor unit, you can condition a very small room to a whole floor. Single zone units offer excellent control and comfort. Then there are multi-zones, so 1 to 3, as shown in the image above, can also be connected to a ductless, ducted, or combination of indoor units. Still providing excellent efficiency when heating or cooling, these units can handle multiple rooms, floors, or the whole house, depending on how they are configured. So while one multi-zone unit could be configured to have enough indoor units to provide a solution to the whole home, manufacturers encourage best practice designs that break up their responsibility to multiple outdoor condensers rather than one. This can increase efficiency, control, comfort, reduce the risk of any performance issues, and add redundancy if one of the systems were to go down. On the next few slides, we'll take a look at a few scenarios to illustrate best practice designs that can be applied to most homes in our area. Our example will be using a small 2-bed, 1-bath house that's maybe 1,300 square feet or so, and has completed all the weatherization recommendations from their energy assessment. So our first example, trying to condition too much space. So this is a scenario of someone putting in a single zone unit for the entire house. 1-to-1 or single zone units have the highest efficiencies in the ductless category, and these homeowners will get to enjoy that low operating cost. The unit is going to run really hard and try to keep up, but you're still going to have a temperature difference between the living room area and the bedrooms. So in this house, from where the heat pump is in the far left of the dining area, it might be 35 feet or so to the bedrooms. So in the dead of winter, they have their heat pump cranked up really high to try and provide enough heat throughout the entire house. But they're still going to have a 4 to 5 degree temperature difference between those spaces 35 feet away. It just can't provide enough heat for the whole home and distribute it evenly. So a similar effect could be felt in the height of summer, where the far bedrooms might get a bit warmer than is comfortable, especially if the sun is pouring in the windows. So let's take a look at the opposite scenario. So maybe these homeowners gravitated towards something where they have heat pumps or want to have heat pumps and control in every single room. They have ductless units in each bedroom and 2 in the living area to ensure nothing is missed. Unfortunately, it's really more than they need. If you were to take a small home like this and you put 4 indoor ductless units on a large outdoor multi-zone condenser that does 50,000 BTU of heat at 5 degrees, it might be double the amount of heat that they really need. So the outdoor condenser is designed for a much bigger house with more heating demands, and it can't operate efficiently in this home. So too much capacity and too little space. This will often happen when creating a design based around how many zones or ductless units you want, especially when it comes to adding one for each bedroom. So how do we make sure the bedrooms are comfortable and we don't have more capacity than we should? Well, there are a couple different strategies. So as mentioned before, when we looked at the first scenario of trying to condition too much space, I stated these homeowners had completed all the weatherization recommendations they received from their energy assessment. So that typically includes things like insulation, tightening the house up, and sometimes new windows. All those things are important to consider when you're thinking about heat pumps. I preface this scenario with a quick note on weatherization because best practice design for heat pumps and weatherization go hand in hand. That in mind, let's take a look at what this design looks like. You can see here that they've placed a wall unit in the living room and a small ducted unit that services both the bedrooms. Those two indoor units could be connected to two single zone systems, one outdoor unit for each the ductless unit and the ducted unit. That design would give them a higher level of efficiency and some redundancy. Or instead, you could put it on a small multi-zone unit if you have limited space for condensers. So bear that in mind. If considering a multi-zone condenser for this scenario, there are limits to how far away the outdoor condenser can be from the indoor unit. And the living room unit is sized to meet the heating and cooling needs of the open living area of the house, and the ducted unit is designed to treat the bedrooms. Sometimes you can also tie in a bathroom or an office to a ducted unit like that as well. So between the indoor units, they meet the needs of the house just right and nothing is oversized, allowing everything to operate efficiently, keeping you nice and comfortable. So let's take a quick look at sound. So A-weighted decibels, or dBA, are often used when describing sound level recommendations for healthy listening. So while the decibel or dB scale is based only on sound intensity, the dBA scale is based on intensity and on how the human ear responds. So because of this, the dBA gives us a better idea of when sound can damage your hearing. And loudness, as in how loud we experience something being, is on a different scale, where moving up 10 decibels from a given level, it will be perceived to us as twice as loud. The opposite, if we move down 10 decibels, is experienced by us as half as loud. So from 70 decibels to 90 decibels, we're at 4 times as loud, or from 70 to 50, we're at 1/4 as loud. As we all know, when you're farther away from something, it's not as loud, right? So this is because of something called the inverse square law, where every doubling of space from the source of a given sound, it is reduced by 6 decibels. So if you were 10 feet away from something and you were experiencing 56 decibels, and then you moved from 10 feet to 20 feet away, it would be down to 50 decibels, and so on as you continue to double your distance away from your original position. So I'm sure many of us here are familiar with the noisy old window ACs or old central AC systems rattling away. Old cooling technology was noisy, no doubt, but modern heat pumps are actually incredibly quiet. So let's take a look. Here we can see the dBA of a number of popular brands of ductless mini splits. These dBA ratings are for their outdoor unit, like the one on the right. I included single zone and multi-zone units for comparison, and you can see they are all relatively similar. The low end is 45 dBA and the high end is 58. That puts us between the sound of your refrigerator makes and a normal conversation. So for example, taking the highest rating seen here of 58 and remembering that if the unit is running at a maximum speed, which it doesn't happen all the time, if I were one foot away from the unit experiencing 58 dBA, 20 feet away from that position, you would experience about 32 decibels. 32 decibels is about the same as a whisper. The loudest heat pump here is rated at 79 dBA. So when it is operating at its maximum capacity. So using the inverse square law we described earlier, let's see how loud it would be. So let's say I'm standing right next to the unit in my yard at my house, and someone else is standing 40 feet away in their yard. I will experience the sound at 79 dBA, and that's about as loud as a window AC. The other individual 40 feet away will experience 40 dBA. 40 dBA is comparable to a library or a refrigerator, and it is approximately 1/8 as loud when standing 40 feet away. So let's say you were only 20 feet away, so half that distance, increasing the decibels by 6. This is comparable to a quiet conversation, a babbling brook, or your computer running at home. Your own dishwasher running in the next room over from you could be louder. So how about if we use something of an average here between these heat pumps, let's say 60 decibels. 20 feet away, that is somewhere between a whisper and the rustling of leaves. And now that you have a good picture of just how quiet these units actually are, let's compare it to some other outdoor equipment that we're all familiar with and you might be seeing in your neighborhood. So a quieter lawnmower can be around 80 decibels. A typical leaf blower can be up to 90, and some weed whackers up to 100. So from our average of about 60 decibels, a lawnmower is 4 times as loud as a heat pump, the leaf blower 8 times as loud, and the weed whacker potentially 16 times as loud. All right, so as we've learned, air source heat pumps can come in a variety of shapes and sizes and sounds. And so depending on your home's need, the design that is appropriate for your home, and goals as the end user, the cost can vary greatly. So for small ductless systems that may serve a small to medium-sized room, you could see a cost in the realm of like $5,000 to $8,000 installed. And for systems that are designed to service the entirety of a large home and provide all of your heating and cooling needs, and may include installing some ductwork, the costs could exceed $30,000. So it's important to remember that your operating costs are also going to vary on the system design and outdoor temperature, as we discussed in the previous slide. If you're looking to displace oil, propane, a wood pellet system, electric resistance, you're going to save a bunch of money. And if you're looking to displace a high efficiency natural gas system, your operational cost savings during the heating season may be minimal, but your carbon savings are going to be significant. So as part of the program, Abode curates a participating contractor list. There are a lot of contractors in the community, and despite our best efforts, they may not be on the list, but we're here to engage with them and explain how to file for the rebates. We're not directly endorsing any particular contractors, but contractors on this list have passed an application process with Abode. We check to make sure they have attended relevant manufacturer training for the products they install, check references on their work. They've committed to provide high quality customer service to operate in the program. And they're also familiar with the pre-approval and install QA steps of the rebate process. So customers are not required to use contractors on the participating contractor list. As long as the pre-approval and install QA steps are followed by your contractor, you can still receive a rebate. And contractors on the list are already familiar with that process. So let's take a look at that process. So in order to receive a rebate, your contractor must submit a pre-approval form prior to installation and an install quality assurance form after installation is complete. Pre-approval form is where the contractor submits information about the home and system planned to be installed. When we receive the pre-approval form from the contractor, we'll consider, is the equipment reasonably sized for the space being conditioned, type of floor plan, and the building envelope? Is the equipment selected appropriate for the type of floor plan and intended use? And are we optimizing runtime and use? If all those make sense, we would pre-approve the project. The install QA is used to ensure systems meet best practice installation guidelines for cold climate air source heat pumps. They're going to provide key photos of the installed equipment and site conditions. And then we're going to respond to some attestation questions regarding the steps of the install. And surveys are also used to ensure participating contractors are continuing to provide great customer experiences, and we strongly encourage customers to complete them after the job is complete. So let's take a quick look at Hmlp's rebates that they're on offer. So the qualifying products are everything that we've seen so far. The rebate amounts are $500 per ton up to $2,000. And the efficiency requirements is that the system must be listed on NEEP's cold climate air source heat pump list. And that list can be accessed from Hmlp's website, our website, or you can search for it. And many contractors in the area, if not all contractors in the area, are totally familiar with that list. There's also an adder. It's a $250 weatherization adder if completing installation along with your heat pumps. So that's in addition to the standard weatherization rebate that is offered by Hmlp, which is 50% of installation project costs up to $1,000. So all in all, you could be looking at quite a bit of money that's available to you, especially if you're going to be doing heat pumps and also insulating your house at the same time, which is a great idea, as we're talking about earlier. All right. So with that, I want to thank you all for attending. We look forward to speaking with you. If you'd like to set up a consultation with us, I encourage you to go to the website right there below. And as you look around, you'll be prompted to schedule with us. So with that, I'm going to open it up for questions, and I'm going to start with what is in the QA in the chat box. All right. Laura has asked, what's meant by low, medium, or high static? So basically, that's like a classification to differentiate between those different types of heating air handlers. So I can switch back to that quickly here. Oh, there we are. So On the left, it has like a low static. So it's like a very like low pressure of air that's moving through that air handler. And so it is not designed to service like a large area, and it's going to have like gentler air that's moving through it, to kind of put it in a simple way. And then in the medium static category, I can do a little bit more, like it can service a little bit of a larger area because there's more air being pressured to move through that ductwork. And then on the far side, you have the high static one there. All right. The question here from Steve, does Abode interface with the MA HeatSmart program? We have worked with folks that have been involved in that program, but we don't administer any of those programs ourselves. We do sometimes in different communities around Massachusetts. We've done some QA for them for programs like that. We have offered no-cost consulting for different programs that different towns are running as well. So we're involved in 11 different communities total right now in Massachusetts. Steve also asked, what is the refrigerant? The refrigerant that's used in heat pumps today is R410A. So that refrigerant, it does not harm the ozone layer. It does contribute a little bit more to global warming if it were to leak than I think many of us would prefer. But right now, the US is working on transitioning to a new refrigerant that has a lower global warming potential. So we're all excited about that happening sometime soon. However, a good quality heat pump install, the refrigerant will not leak out of the system. So there's no need to worry there. Steve also asked, can air to air and air to water be combined? We have an oil boiler for both heat and hot water. So potentially, there are a lot of cool technologies that are starting to come out and surface. I'm excited to see what becomes a possibility. There may be units in the not too distant future that is one outdoor condenser that can connect to ductless units on your wall in your house. They can also heat your hot water, and maybe they could also help heat some of the water going through your hydronic systems around your home. All right. Edwin has asked, what are the downsides to heat pumps? Are there any? So of course, there are some downsides. I do paint them in a good light here. They do have many benefits. It is really the future of heating and cooling because they really are better all around. What you do want to watch out for is, having a system that is not designed well for your home. Like systems that are drastically oversized for your house, they can have impacts on your comfort, impacts on the efficiency, things like that. And there are different types of heat pumps out there that are meant for different scenarios. So there are, let's call them your cold climate heat pumps. And then you have maybe like a standard heat pump. A cold climate heat pump is better designed for our area, like it sounds like it is, because it does a great job of maintaining its heating capacity. Even when it gets down to like 5 degrees outside, it still has 80, 90, 100% of its total heating capacity. So that's something you could rely on for all your heating needs. And it can continue to operate well into the negatives, into temperatures we don't really see around here. And then there are the standard heat pumps, and those are more so designed for like a hybrid solution where you have a backup that you plan to use and you will continue to plan to use, because the standard heat pump doesn't do as good of a job of maintaining all of its heating capacity when it does start to get colder outside. All right, I have some other questions here in the chat box. From Elaine, does this work with a whole house space pack system of air conditioning, high velocity cooling? So there are some heat pumps that are coming out that do work okay with the high velocity systems. It can be tricky sometimes to get a rebate for those just because of some like technicalities when it comes to certifying the efficiency of those. And there are more emerging technologies that are coming out that do work with that high velocity ductwork. So it's still a possibility for you. And I would encourage you to set up a chat with us so we can kind of discuss that further. Matthew's asked, do you also replace existing forced hot water baseboard with new low temp hot water baseboard? What is the approximate cost to do this in a 2-floor, 2,500 square foot house? I won't be able to answer the second question very accurately, but the first question I could answer. Folks that are looking to use an air to water system to update their forced hot water baseboard around the home to new low temp forced hot water baseboard, that can be a possibility, but sometimes it can be tricky depending on the piping that you have going around your home. So these systems work better when there are more what's called home runs, as in, each of these areas around the home that you have baseboards, they go to and from the boiler individually. And that way, the water that goes out and returns, it's going to be cooling off as it heats those areas, right? But say you had one big long run for that whole space. By the time it gets to the far end of that space, the water in those pipes is going to be kind of cool and it won't be able to provide any heat to those areas. So if you don't have many home run scenarios in your house going to all those different zones in the home, it can be pretty tricky to retrofit all of that. All right, how are heat pumps protected? Cynthia's asking, how are heat pumps protected from snow during blizzard situations? Thinking of the winter of 2015. So outdoor units are recommended to be installed with at least 12 inches of clearance off of the ground. And so many folks will go 12, 18, 24. You can hang them on the side of your house. There are mounts that they can stand on, and all those give them nice clearance off the ground. You'll want to make sure that they stay clear of debris and such, and you don't want to install them beneath like the drip line of your home if there's no gutter, because you don't want like water dripping off or icicles dripping onto them or snow falling onto them, because they don't have to clean them off all the time. A lot of folks will even actually just kind of build like a little roof over them if they want to. So I've seen that sometimes as well. Just want to make sure they continue to have the right amount of airflow going through them. But typically just that stand, keeping it off the ground, is going to do a great job. All right, and Julie asks, are there any scenarios that a house would not be able to add this type of system? Usually there's some way to install air source heat pumps in your home. They're so versatile with like the different types that we've been looking at here. So you have these ducted units, you have the ductless units, and you can combine and mix and match all that kind of stuff to typically make it work somehow in most homes. With that being said, it may not always be a good fit for everybody. But if you're curious about that, please just set up a chat with us and we can kind of figure out what makes sense for your home. All right, another question from Edwin. Is the heated air dry air? How do you keep the air appropriately humid? I love that question. So with there's two answers here. And so with the lack of humidity in a home, that can have a lot to do with air infiltration in the wintertime. And so let's say it's really cold outside, really cold air, it can't hold as much moisture, but that nice warm air inside your house, it can hold quite a bit of relative humidity and makes it comfortable for us. If you have a leaky house and there are some areas in your home where there's a lot of air infiltration or exfiltration, it's leaking out, that warm, moist air, it's leaking out of your home and it's being replaced by that cold air outside that can't hold as much humidity. So over time, if that process continues and there's not enough new humidity being added to the air, which happens naturally from just being in the house, we release moisture, cooking, showers, plants, things like that. They all release a little bit of moisture into your home. And so if you can reduce the air leakage in your house, you can also at the same time keep the humidity at a more comfortable level for a longer period of time. And it should remain so naturally more comfortable. The air that comes out of ducted heat pumps is not as hot as the air that typically comes out of traditional systems. And so the air not being as hot, the relative humidity in it should remain a little bit higher as well, which overall should help the humidity issues in the home. Many folks, if you do have major issues with that and there's not really a good way to seal up the house to try and deal with that, because that can kind of be the root of the problem, some folks will install whole home humidifiers onto their ducted system as an alternative. So I have a question here. Can I explain COP? Sure. So looking at this chart here with the bar with the green arrow, I have seasonal mini split COP there. So heat pump or a mini split. What is the COP? The COP is the coefficient of performance. Basically what that means is, how much energy are you putting in and how much are you getting out? And that equation will provide a COP. The higher the COP, the more efficient. All right, Anthony has asked, for help with designing a solution, do we interact directly with Abode or is the first step to choose a contractor? So I suggest for initially getting in touch with us to have a conversation. We can chat about your home, maybe give you some ideas, feedback, answer your questions, and help prepare you to get your quotes. That way, overall, you'll end up with a a better experience getting those, hopefully end up with a system that's more aligned with what you need. And you can continue to engage with us throughout the entire process. But as I stated, contractors in the home who are looking at things, measuring things, running those heat load calculations are best situated to design your system for you and everything. So we're here to provide the feedback and help you out, but we're not here to design your system for you. Steve has asked, does Abode work with any non-muni towns? So we are working with other communities in the state. We're working with Cambridge, as well as some Metro West towns like Ashland, Framingham areas out there to run some QA or some no-cost consultation programs. We're working with Acton as well. Can a heat pump act as an alternative to a dehumidifier without heating or cooling the home? So it will cool the home when it is in dehumidification mode. Many heat pumps have that. You can tell it, I want to dehumidify, and it will focus on that. But while it is doing that, it will cool the space. All right. What is the typical payback time for a heat pump retrofit? It's really going to depend on the situation, your existing fuel type you have, how expensive that fuel type is to run, how efficient your existing system is, all of that. So if you want to chat with us, kind of give you some more basic details on what that might look like for your home, please set up a time to chat with us. That'd be great. All right. Does a heat pump system work in all electric home situations? Your people who have all electric homes, you are best situated to switch to heat pumps. As you can see, resistance here, the bar all the way on the left, you're spending the most to heat your home. And so if you have the opportunity to maybe switch over to heat pumps, it would be great going from that bar all the way on the left to that bar in the middle. And so definitely get in touch and help us speak with you about what might be some good options for your house. All right, I don't see any more questions coming through at this time. Give it a moment. So, well, thank you all for coming. If there's any more questions, it was really great speaking with you all. A lot of good questions. Appreciate that. Tom, did you want to share anything before we close out?
No, I just want to thank you, Chris, for coming out tonight, and for everyone else that joined us. Great questions. And again, if we can help, if Abode can help you with anything, please use them as a resource.
Great, thank you, Tom. I'll get to that one last question that was in there. So this bar chart uses Hmlp's electric rate. So it's using the electric rate that all the folks here on this call have access to. All right, well, I'll show the link one more time here before we close out, so that if anyone wants to schedule, please go to that website. There's a link there that you can use to schedule an assessment. So thanks again for coming. Thanks, Tom, for having us. This was great. Really appreciate it. And we're all very excited about this program and to get things up and running. All right.
Thank you all. Have a good night.